you're in grade 10, 11 or 12 and you're struggling with electricity, then this video is yours. In this video, I'll be sharing my secret recipe on how I cook electric circuits. Paddle up, let's cook.
So let's look at this worked example 1. So in this worked example, we're given a circuit below, and then the connecting wires and the battery have negligible resistance, right? So meaning the internal resistance of the battery is negligible, right? So now the first question says we have to define the term resistance. So what is resistance? So I would like us to start here. I would like us to start equation R equals to V over I, right? So now we can see that from here resistance is the potential difference over current. So we can eventually define resistance by saying resistance is the ratio of the potential difference and the current. In a circuit. So this is the definition of resistance. It's actually the ratio of the potential difference and the current in the circuit. So now, this is the secret recipe that I want us to share. So now, I want us to look at this circuit and consider these resistors in parallel. We're going to consider these resistors in parallel as one resistor, and we are also going to consider this resistor here, which is a 2 ohm resistor, right? So now we are going to redraw this circuit. We're going to redraw the circuit just here. Remember here, this is a 2 ohm resistor. And then we are going to also draw the parallel resistor as one resistor. And then just going to draw something like this, and then like this. And then I'm going to include this voltmeter here. And I'm going to put my voltmeter here, which also this is going to be the voltmeter of the parallel resistors, right? And then I'm also going to put my switch here and the batteries here. Batteries. Then I'm going to also put my EMF, since this will be called EMF when the switch is open, and then when the switch is closed, this 24 voltage here is going to be called the terminal potential difference, V terminal. So that's the difference between the two. So now when the switch is open, this is called EMF because it measures only the potential difference across this battery. But when the switch is closed, this potential difference will now be referred as the terminal potential difference. So now we are going to use this secret recipe. So this is my secret recipe actually. So now I'm going to write something here. Remember, the most important one is Ohm's law, R equals to V over I. And then, or if you want, you can write this one, V equals to IR. Remember, this is one and the same thing. This is Ohm's law. So now I'm going to remember when these two resistors here, they are in series, right? So you're going to say these two resistors are in series. So you're going to say R1 plus R2 since they're in series. And these two resistors here are in parallel. So you're going to say R in parallel equals to 1 over R1 plus 1 over R2, right? So now, remember we have two different kinds of scenarios here, but I want you to check this out. When we are going to discuss the current in parallel, remember this, it's in parallel, and then we are also going to discuss the current in series. So what happens to the current in series? Current remains the same, right? Current remains the same in series, so it's equal. And then what happens to the current in parallel? The current in parallel is being divided. So in parallel, the current is being divided. We have what you call current dividers. Right. So now, what happens to the potential difference in series? The potential difference is being divided in series. The potential difference is being divided. So you're going to say V1 plus V2. So now, I want us to talk about this. Right. What does potential divider actually mean in series? It means this terminal potential difference will spread. This one will take its own potential difference, and also this one will also take its potential difference. And then when we add the two potential difference, we have to get 24, right? So this one plus this one has to give us the terminal potential difference. Same thing applies to the current. The current, if here we have the current total, the current in parallel, so the current of 24, so this current will separate, will split, meaning this current here, this current will move from here, and then the other one will go here, the current will go here, and then the other one will go inside here. So this current will separate, will split, meaning the current total will be equals to the current of 24 plus the current of 8 ohms. So now, what happens to the potential difference in parallel? So the potential difference remains the same. In parallel, it remains the same. Why do I like putting I like current? So now, the potential difference remains the same. So now, this is my secret recipes. So we are going to use this secret recipe to answer all these questions. So now, I want you to remember this even during your exams. Just make sure that you remember all this before you go inside the exam or before you answer a electric circuit question. So now, let's look at the first question. The first question says we have to find the total potential difference. Or now 1.2.1 says that we have to determine or calculate the equivalent resistance of the resistors connected in parallel. We are talking about the purple the purple or the violet resistors, right? So we're talking about these ones. So we're going to say 1 over R parallel will be equals to 1 over R1 plus 1 over R2, and then we go ahead and substitute. Whether it's R1 we put 24, so it's 1 over 24 plus 1 over 8, right? So you go ahead and punch 1 over 24 on your calculator. So say 1 over 24, giving us 0.41667, and then we're going to add this with 1 over 8, giving us, so 1 over RP will give us 0.167, so 0.16667. So now, since we are not looking for 1 over RP, we are looking for RP, we are going to raise the left hand side to the power of -1 and also raise the right hand side to the power of -1, so that this one can be RP, so that the numerator can be the denominator and the denominator can be the numerator. So therefore RP will be equals to what? Will be equals to 1 over 0.2. So this is going to be 1 over 0.16667, which is equals to, this is closer to 6, right? So I will round this answer to the nearest 6 ohms. So resistors in parallel, RP, will be equals to 6 ohms. So whether it's RP, here on my favorite sketch, I'll put 6 ohms here. Right. So now we are looking for RP, so we found our RP. So now the next question says that we have to determine the total resistance of the circuit. So the total resistance of the circuit, since we found this, we are only left with this one, right? So we know that this one and RP, they are actually in what? Series. So now we can see, therefore, for 1.2.2, R total will be equals to R1 plus R2. Since all they are connected in series, we can say R1 plus R parallel. So this, I'll say this one is R1 and this one will be R parallel. So we know that R1, our R1 is 2 ohms, and then the R parallel is 6 ohms, and then 2 plus 6 will give us 8 ohms. So this will be our total potential difference. I mean our total resistance. So now, this is basically how we solve this kind of questions using our secret recipe. So now let's look at 1.3, right? It says that when the switch is closed, right, the voltmeter connected across the 2 ohm reads 6 voltage. So we're going to write 6 voltage here, and then they say determine the potential difference across the parallel combination, meaning we're looking for RP, we're looking for this one, right? So we're going to use our secret sketch here. So we know that, remember I said the V terminal, when it's connected in series, it's being divided, right? Potential divider, right? So we are going to use this one. So remember for 1.3, it's easy. We're just going to say V terminal will be equals to V plus V parallel. Remember this is V and this is V parallel, right? And then we're looking for V parallel. So V terminal, we already know what is V terminal. V terminal is 24, and then V is 6 plus V parallel. So therefore we'll take the 6 that side. So V parallel will be equals to 24 minus 6, and then 24 minus 6 will give us 18V. So here it's 18V, and then we can see that 6 plus 18 has to give us what? The V terminal, right? So now that's how you basically solve this kind of questions. So now always the last questions are the theoretical questions. I want you to notice, or I want you to bear that in mind, that always the last questions are actually easy but a little bit challenging sometimes. So I would like us to look at this question. I would like us to look at this question 1.4. So 1.4, we're given a charge. So I would like us to always look at your formula sheet. Whenever they're talking about the charge, you write the formula that has charge in it, right? So the first formula that has charge is equal, it's I, it's the current. Remember, current is the rate of flow of charge, right? And then it has charge. So this is the first formula that comes in mind, right? So now we're given charge 8 coulombs, and we're given its time. So we're going to use this formula. We're going to say I equals to Q over T. Then our charge, we're given 18 coulombs, and our time, we're given 6 seconds. And then this, therefore, our charge will be equals to 3 amperes, right? So now they say calculate the current in the 2 ohm resistor. So yeah, that's our answer. So we were supposed to find the current, so that's basically it. We found the current in the 2 ohm resistor. So let's go back. Let's go back and not hurry. So remember what I said. You read the question, right? You look at what's given, right? We're given the charge, we're given time. So we go to our formula sheet. This will be given on your formula sheet. So now you look for a question that has a Q and time. Remember, we're given charge. You have to look for a formula that has charge and time in it, which is this one, I equals to Q over T. And then now you write that formula, and then after you substitute what's given. Hence I substituted 18 and 6, right? And then you eventually find your current. So now the question says calculate the current, right? Which is what we are calculating. Calculate the current in 2 ohm resistor, right? So now remember here, we were only just given the charge that moves through a bit, right? So how did I come to the conclusion that this 3 amperes is the current that passes through this 2 ohm resistor? It's because of the statement, this secret recipe of mine. Because current in series resistors remains the same, meaning current here will be equals to current here and also be equals to current in the battery. So current remains the same in series circuit.